So adding on to what we were doing in section 3.3 with slopes, now we're going to be doing the slope-intercept form of the equation of a line. So the slope-intercept form for the equation of a line, every non-vertical linear equation will always have a y-intercept, meaning it's always going to be crossing the y-axis. So what that means is that an ordered pair 0, b will be on the line. So that's just a fancy way of saying that the y-intercept is something, which we're calling b for now. So remember, y-intercept means the x-coordinate is 0. So if we start with the slope formula, I'm going to do a little, see how we get this formula here. If we start with the slope formula, m equals y2 minus y1 over x2 minus x1, and we know that there's a y-intercept, what we can do is we can substitute 0, b into x1, y1, which means we would get m equals y2 minus b over x2 minus 0. If we solve this for y, we're going to end up getting the slope-intercept form for the equation of a line. So what we would get here is m equals y2 minus b over x2, the 0 goes away, and then we would get, we could cross multiply x2 on both sides. We would get mx2 equals y2 minus b, and then we would add b to both sides, and I'm just going to write the y2 on the left. We would get mx2 plus b. So instead of having to write that little subscript 2, we just write it as we have it right here, y equals mx plus b. So x and y is any coordinate, any xy coordinate on the line, m is the slope, and b is the y-intercept. Okay, so I'll just label that. B is the y-intercept, and the m is the slope. So that is the slope-intercept form for the equation of a line. So let's identify them given some linear equations. So determine the slope and y-intercept. The first one, we have y equals negative 2x plus 3. So the slope-intercept form, y equals mx plus b. The slope is multiplying on the x. The y-intercept is plus or minus afterwards. So the slope is negative 2, and the y-intercept is 3. For the next one, we have y equals x. So our slope multiplying the x, there's technically a 1 out here. Coefficient of 1 if it's not written. So that's a slope of 1. And if there's nothing written after it, that's like saying plus 0, so the y-intercept is 0. And for the last one here, we have y equals negative 7/9 x minus 5. So we have the slope multiplying the x, y-intercept afterwards. The slope is negative 7/9, and the y-intercept is negative 5. Okay, so easy enough for that. So we're going to be using those two pieces of information to actually graph linear equations that are in slope-intercept form. So the steps for doing this is we're first going to plot the y-intercept. So we're just going to identify the y-intercept and we're going to plot that point. Then we're going to use the slope to find a second point on the line from that y-intercept. And what we're going to do is, if it's not written as a fraction already, we're going to rewrite it as a fraction and use the fact that it's rise over run, change in y over change in x. We're going to draw a straight line through those 2 points with arrows at the end, and then we're done. Because we only need 2 points plotted in order to graph a linear equation. And this little note right here is just something to keep in mind. If we have a positive slope, we're going to go up and to the right. If the slope is negative, go down and to the right. So essentially what I do is, if there's a negative, I just put it with the numerator, and that'll tell you to go up or down, and then you always go to the right. Technically, you could go, if the slope was positive, you could go down and to the left, and if the slope was negative, you could go down and to the right, but I think it's just easier to, or sorry, you could, if it was slope was negative, you could go up and to the left. But as you can see, it's probably just easier to stick with this one method for doing it so you don't get it confused. Okay, so let's graph them. So for the first one, graph y equals negative 3/2 x plus 2. So let's find the slope and the y-intercept. So the slope is negative 3/2, and the y-intercept is positive 2. So we're going to plot that. Y-intercept of 2. The slope negative 3/2. So what I'm going to do is I'm actually just going to erase that, and I'm going to put that negative with the numerator. So that means we go down. So numerator tells us if we're going up or down because it's the y coordinates. Denominator tells us if we're going right or left. But the way that I do it, we just always go to the right. So we're going to go down 3 from that y-intercept. So 1, 2, 3, and to the right 2. So that would be our other point. So I'll put down 3 to the right 2. And all we have to do is connect those points with a straight line. Put an arrow through it, and we're done. And I'll just label it. Oops. Okay, and then for the next one, y equals 3/5 x plus 1. Well, going back to the other one real quick, we can see that we have a negative slope. So that means our graph should be falling from left to right, which it is. That's kind of a good way to check to make sure you didn't mess anything up also. Next one, y equals 3/5 x plus 1. So slope, y-intercept. Our slope is 3/5. Our y-intercept is 1. So we plot down that y-intercept of 1. So we use the slope, it's positive. So that means we're going to go up 3 and to the right 5 starting at our y-intercept. So we're going to go up 3, 1, 2, 3, to the right 5, 1, 2, 3, 4, 5. Connect those with a straight line, and we're done. And that's y equals 3/5 x plus 1. And I'll just label, this will be the last one that I label like this, but we go up 3 to the right 5. Okay, next one, y equals negative x minus 2. So for our slope is, there's just a negative, which means it's negative 1. And our y-intercept is that negative 2. So let's plot that, let's plot that point for the y-intercept, negative 2. For a slope of negative 1, we want to write it as a fraction. So we have an integer here, just negative 1. Writing it as a fraction, we just put it over a denominator of 1 every single time. So this is going to be negative 1 over 1. The negative means we're going to go down 1. And then denominator, we're going to the right 1. So we start at the y-intercept. We go down 1 to the right 1. Puts us right here. We connect those points. Arrows on the end. And we're good. That's y equals negative x minus 2. So before, when we were doing these, we were doing it by plugging in x values, finding their corresponding y values, and then plotting that xy coordinate. So this way is a lot quicker. Next one, y equals 6x minus 8. So slope, y-intercept. So plot that y-intercept, negative 8. So a slope of 6 is going to mean that is the same as 6 over 1. So we're going to go up 6 units and to the right 1 unit. So 1, 2, 3, 4, 5, 6 to the right 1 puts us right here. Connect the points, and we're done. Okay, so hopefully that wasn't too bad. So for the next thing, we're going to be creating the equation this time. So we're going to use the slope-intercept form to help us actually write these equations. So if we're given the slope and we're given any point on the line, so technically there's an infinite number of xy coordinates that will be on the line. If we're given one of them, what we can do is actually write this in slope-intercept form. So for this first example here, let's write an equation in slope-intercept form of the line passing through 0, -1, and this with the slope 2/3. Okay, so we want to write it in this form, y equals mx plus b. So we're going to be leaving x as x and y as y because they're the variables for the equation. We have m already, but we don't have b. In order to find b, we have to plug exactly what we have in here, where this is x and this is y, into this equation and solve for b. So it's going to be -1 equals 2/3 times 0 plus b, plugging in that coordinate. So that 0 term actually cancels and we get b equals -1. So the y-intercept is -1. We also probably should have been able to realize that because the point that they gave us, 0, -1, when x is 0, that is the y-intercept for your y-coordinate. So writing this as in slope-intercept form, it's going to be y equals mx plus b. So it's y equals 2/3 x minus 1. So pretty much the only work you have to do is find that y-intercept and then plug in the slope and the y-intercept into y equals mx plus b. Let's do another one of these ones. So we have 2, 5 and a slope of 4. So it's passing through the point 2, 5. We're given the slope, so let's use all of that information to find the y-intercept. So y is going to be 5, so 5 equals 4 times 2 plus b. 5 equals 8 plus b. Subtract 8 on both sides. That's going to give us b equals -3. So I had to skip showing the intermediate steps. So that's all the work that we need. So y equals m, which is 4, x minus 3. So y equals mx plus b. Okay, and then for the last thing here, that was coming up with a line, equation of a line that was not horizontal and it was not vertical. So now let's come up with equations that are horizontal and vertical. So for this example, let's write an equation of a line passing through the point -2 or 2, -2. And for the first one, saying that it has a slope of 0. Okay, so what this means is, let's plot this down real quick. So 2, -2, 1, 2, 1, 2 would be right here. A slope of 0, this is m equals 0. What that means, there's kind of two ways to think about this. What this means is that this is a horizontal line, right? Slope of 0 is a horizontal line. The short way to do this is to recognize that a horizontal line, to remember from a few sections ago, is going to be in the form y equals a number. So it's going to be y equals something. It's going to be y equals the y-intercept, which is just -2. So you could do it the other way that we were just doing it and recognize that there's the point xy on the graph, which is 2, -2, and then use that slope of 0 to find the y-intercept. But you would just end up getting a y-intercept of -2. Slope of 0 would cancel the slope term, so just y equals -2. Okay, for the next one, so the reason why I thought it was easier to think of it that way is because of this next one. So for an undefined slope, once again, we're passing through the point 2, -2. Undefined slope is vertical line. So when it's a vertical line, hopefully we remember vertical lines are always going to have the form x equals a number. It's going to be x equals the x-intercept, which in this case is just x equals 2. So x equals whatever that x coordinate was. So pretty easy for these ones. You just have to remember the equations for vertical and horizontal lines. Okay, so that's actually it for this section. In section 3.5 now we'll be doing point-slope form of a linear equation and then doing some modeling at the end. So we've already done slope-intercept form, so this is going to be one of the other main forms for an equation of a line. So starting with this first thing here, we can use the slope formula. So all these are based on the slope formula. They're all technically the same thing, just rearranged a little bit. So we can use the slope formula to obtain this point-slope form for the equation of a line. So we're going to have slope m with point x1, y1 on it. So that means if we're starting with the slope formula, so remember the slope formula is y2, m equals y2 minus y1 over x2 minus x1. So for this, we're going to say that x1, y1 is a point on the line, and I'm going to let x2, y2 just be y and x. So it's going to become y minus y1 over x minus x1. So I'm doing this because it can represent any point on the line. So what we can do now is actually multiply both sides by that denominator, essentially cross multiplying. So we would end up getting m times x minus x1 equals y minus y1. And all you have to do is rewrite it so the y's are on the left, and you get the point-slope form equation for a line. Okay, so point-slope form is y minus y1 equals m times x minus x1. So you can see that we need a point x1, y1, and we need the slope m. And x and y are going to remain variables. So let's do an example here. Write an equation in point-slope form for the equation with slope 4 passing through the point -1, 3. So m is 4 and x1, y1 is going to be -1, 3. So before I actually do it, I'm going to go to that point -1, 3 is right here. Slope of 4 is 4 over 1. So 1, 2, 3, 4 over 1. So that's going to be this line right here. So we're trying to come up with an equation for this line. So we're going to use y minus y1 equals m times x minus x1. So we're going to plug in y1, which is 3, m is 4, and x1 is -1. So I'm going to simplify that x minus a -1, make it x plus 1. So this right here is going to be point-slope form. And now let's solve it for y to get it in slope-intercept form. So solving this for y, we have to always distribute the slope. So it becomes 4x plus 4 on the right. And then we're going to add 3 to both sides. So we get y equals 4x plus 7. And this is our slope-intercept form. Okay, so you can see that it looks correct. It looks like we have it passing through the y-intercept of 7. It has a slope of 4, so it looks pretty good. Okay, so another one, write an equation in point-slope form with a slope -1. So m here is -1. Passing through the point x1, y1, which is 5, -3. So starting with slope-intercept form, we have y minus y1 equals m times x minus x1. So plugging in for y1, it's y minus a -3 equals m, so -1 times x minus 5. I'm going to simplify this left-hand side. We get y plus 3 equals negative x minus 5. So you could have that negative 1 there. I'm just going to leave out that negative 1 and just write it as a negative in front. So once it's kind of simplified a little bit just like this is going to be point slope. So that's point slope form. And then solving this for y is going to be distribute the negative on the right, so we get negative x plus 5, and then subtract 3 on both sides, we get negative x plus 2. And this is going to be slope-intercept. So graphing this, we have the point 5, negative 3. So 5, negative 3 should be about right here. With a slope of negative 1, that means down 1 to the right 1. So that would look like this. So that would be our line. And it looks right. It looks like it's passing through a y-intercept of 2 with a slope of negative 1. Okay, for the next thing here is parallel lines. So we probably know what parallel means. Two non-intersecting lines are what we call parallel. The more math definition of it is two lines are parallel if and only if they have the same slope. So same slope technically would be a different y-intercept also, so they're not just the same exact line. So parallel lines have the same slope. So let's do some questions where it mentions and uses that fact. So the first one here, let's write an equation of the line passing through negative 3, 1, and parallel to the line whose equation is y equals 2x plus 1. And then express it in point slope and slope intercept. So we have the point that it's passing through. That's going to be negative 3, 1. So when we're starting our point slope form, we're still missing the slope. So we have to use the fact that it says parallel to another line. So we have this other line, y equals 2x plus 1. Y equals 2x plus 1 would look something like this. So that would be y equals 2x plus 1. Just going to label it 2x plus 1. And our line is going to be passing through negative 3, 1, which is right here, and it has to be parallel. So if it's parallel, it's going to look like this. So they're parallel, they're never crossing, so we're trying to come up with the equation for that line, and that's going to be our line. So since they're parallel, that means same slope. So the slope that we're going to be using, we're going to go to the other line. It has a slope of 2, and we're going to steal that one slope because it's the same. So it has a slope of 2, and once we have that, we can do it exactly how we just did it previously. So it's going to be y minus 1 equals 2 times x minus negative 3. Y minus 1 equals 2 times x plus 3. So this is our point slope. Solving this for y to get it in slope-intercept form, distribute the slope of 2. We get 2x plus 6. Add 1 to both sides, we get 2x, y equals 2x plus 7. And that's going to be slope-intercept. So let's go back and make sure it makes sense. So they both have the same slope of 2. And the line that we drew down here is going to be 2x plus 7, and it does look like it crosses the y-axis at 7. So I'll label it just because there's 2 on here. Okay, and let's do one more, make it a little bit harder. So write an equation of the line passing through 5, 0. So we have x1, y1 already. It's 5, 0. We need our slope, and we're told that it's parallel to the line x minus y plus 2 equals 0. So that is not in slope-intercept form yet. So what we have to do is rewrite this equation x minus y plus 2 equals 0, and use the fact that the lines are parallel, so same slope, and then steal the slope. So solving this for y, what we could do is just add y on both sides, and we would get y equals x plus 2. So the slope here is going to be right out front of the x, multiplying the x, which is just a coefficient of 1. So our slope is 1. So it's just as easy as that. So it was just one step further than the other one. So going to point slope form, y minus y1 equals m times x minus x1. Plug in our values here. So it's y minus 0 equals 1 times x minus 5. And I'm just going to say it's not very simplified, but I'm just going to say point slope here. Because when we solve this for y to get it in y-intercept form, it's actually pretty easy. Just distribute the 1, which makes everything the same, so it's just x minus 5 on the right. And since it was y minus 0, we're actually done. So we get y equals x minus 5, and this is slope-intercept. So our line is going to be x minus 5, so start at negative 5, slope of 1, so something like that. So y equals x minus 5. If we graph the other line, we would see that they're parallel. Okay, so that's parallel. So the other one that we will be doing is perpendicular. So two lines that intersect at a right angle, which means 90 degrees, we call those lines perpendicular. The slopes of perpendicular lines are negative reciprocals of each other. So that means if we multiplied them together, the product would be negative 1. So to find the negative reciprocal, we just have to negate the number and take the reciprocal. So it's pretty easy, but definitely know that term, negative reciprocal. So for example, let's write an equation of the line passing through negative 3, negative 5. So that's going to be our x1, y1. And we know that it's going to be perpendicular to the line whose equation is x plus 2y minus 8 equals 0. So we need our slope, and we need to use the other equation of the line to find the slope using the fact that it's perpendicular. So first we have to solve this for y to get it in slope-intercept form so we can find the slope. So if we subtract x and add 8 to both sides and then divide by 2, I'm just going to do it in one step here. It's going to be negative 1/2 x plus 4. So the slope of this line is negative 1/2. That means the slope of our line is the negative reciprocal of negative 1/2. If you negate a negative, you get a positive, and the reciprocal of 1/2 is 2. So our slope is just 2. So before we do this, let's actually figure out what it's going to look like or get an idea. So negative 3, negative 5, the point is going to be down here. And we know that our line is perpendicular to negative y equals negative 1/2 x plus 4. So that's going to look something like y-intercept of 4, down 1 to the right 2. That'll look something like this. So we know that our line is going to be perpendicular to that. That means if we do a rough sketch of our line, it should look something like this. Might have to adjust that after we're done finding the actual equation, where it's intersecting it, so they're perpendicular at that intersection point. So let's figure out what it actually is here. So I'll erase it. Well, I'll leave it for now. So let's do our point slope form, y minus y1 equals m times x minus x1. So plugging in, we get y minus negative 5 equals 2 times x minus negative 3. Simplifying a little bit, we get y plus 5 equals 2 times x plus 3. and this is our point slope. We had the point, we had the slope, created point slope form. Solving this for y, going to distribute the 2, that's 2x plus 6. Subtract 5, we get y equals 2x plus 1. So that's going to be our slope-intercept form. So yeah, let's go back and adjust our line a little bit down here so it's a little bit more accurate. So that's a y-intercept of 1, a slope of 2. So if we went through and we connected all of those dots, we'd get this line right here, which that even looks a little better than the rough sketch that I had. This is our line, and we can see that it is perpendicular to the red line, which is what it was supposed to be, intersecting it at 90 degrees, and still passing through the point -3, -5. Let's do one more of these to make sure we're good. So write an equation of the line passing through the point, -2, 6, and we need the m, and it's perpendicular, so negative reciprocal slope again, to the line whose equation is 2/3 x minus 1. So this one this is already in slope-intercept form, which is great. So this one's slope is 2/3. That means our slope is -3/2. So negative reciprocal, that's -3/2. So we're going to be using point slope form again. And let's graph it just to get an idea. So the first one, y equals 2/3 x minus 1. 2/3 x minus 1. So y-intercept of -1. Slope of 2/3, up 2 to the right 3. So our line needs to be perpendicular to this one, and it also needs to be passing through the point -2, 6. So -2, 6 is about right here. So we already know it's going to look something like this, because it has to be perpendicular, but let's see what it actually is. Okay, so we have y minus 6 equals -3/2 times x minus -2. Clean up that one part here, we get y minus 6 equals -3/2 x plus 2. So that's going to be our point slope form. Solve it for y to get it in slope-intercept form. We get distribute the -3/2. We get -3/2 x minus 3. So -3/2 times 2 is -3 because the 2's canceled, which is good. Add 6 to both sides, and we're going to get y equals -3/2 x plus 3. And this is going to be our slope-intercept form, which we're going to use that to graph it correctly. So -3/2 x plus 3. My line was actually pretty close. Let's graph it for real though. So here's our point that we're starting with, the blue one. We go down 3 to the right 2, which is our y-intercept. We also could have used that. Down 3 to the right 2. And there's our point, and there's the line that we just found the equation for. Okay, and we can see that they intersect perpendicularly. I think that's a word. Forming a 90-degree angle. So far we've done, for forms of the equation of a line, we've done slope-intercept form, point slope form. We can also have standard form of the equation of a line. Standard form is when we have the variables on one side, the x and the y on one side, and the constant on the other side. So something like ax plus by equals c. That would be in standard form, where a, b, and c are real numbers, x and y are the variables. So what we can do here is, if we're ever given it in this form, which we have been given it in this form already, we can always solve it for y to put it into slope-intercept form to help us graph it if need be. So let's start with this example. Oops. So let's graph 3x plus 2y equals 12 by first putting it into slope-intercept form. So that just means solve it for y. So solving this for y, we can subtract 3x on both sides first. So subtracting 3x, we would get 2y equals negative 3x plus 12. Divide both sides by 2. We would get y equals negative 3 over 2x plus 6. So negative 3 divided by 2 is just negative 3 over 2. 12 divided by 2 is the 6. So now we can graph it. We have the y-intercept. We have the slope. So 6 is right up here. Slope of negative 3 over 2, we go down 3 to the right 2. So there's our 2 points. Connect them. Create a line. And I'm going to label it with the original. Doesn't really matter. 3x plus 2y equals 12. So that was easy enough. We just have to add the x term to the other side and then divide by whatever the y coefficient is. Okay, and then for the next thing here, let's write an equation of a line using 2 points. So this time we're going to be given 2 points that the line passes through, and then it's just going to say come up with an equation that passes through those 2 points. So to do this, we have to first find the slope. So first find the slope between those 2 points. And then we're going to use one of the points as our x1, y1, and then plug them into the point slope form. Okay, so let's do an example here. So let's write an equation of the line passing through negative 2, 5 and 3, 4. So, and we want the final answer in slope-intercept form. So we have 2 points. So pretty much most of the time, not all the time, but most of the time when we're creating an equation of a line, we're going to start with point slope. So we have a point. We actually have 2 points. We're going to pick whichever one. It doesn't matter. And then we need to find the slope. So we need to find m, which we can do that because it's the slope formula. So what I'm going to do is I'm going to let the first point, negative 2, 5, be x1, y1, and then 3, 4 be x2, y2. So it's going to be 4 minus 5 over 3 minus negative 2. So it's going to be negative 1 over 5. So 4 minus 5 is negative 1, 3 minus negative 2 is 5. So I'm just going to write it like that. Negative 1/5 is our slope. So we can pick whichever point we want to plug in. So I'm just going to use 3, 4. So I'm going to use 3, 4 as the point to plug in. You could use negative 2, 5 if you want. I'm just avoiding the negative for no real reason. So it's going to be y minus 4 equals m, which we found was negative 1/5, times x minus 3. Okay, and then we want this in slope-intercept form, so let's distribute the negative 1/5. So we can already see that we're going to be dealing with fractions. So negative 1/5 times x. Negative 1/5 times negative 3 is positive 3 over 5. When we add 4 to both sides, we're adding fractions. So 3/5 plus 4, I'll do that on the side real quick. 3/5 plus 4. We need a common denominator, which would be 5. So 4 can be rewritten as 20 over 5, which is 23 over 5 when we add them together. So we're going to get negative 1/5 x plus 23 over 5. So this is our answer in slope-intercept form. Okay, so let's do an actual a modeling example, just meaning like a real-world application here. So we have a table that lists the average annual cost in dollars of tuition and fees for in-state students at a public four-year college and university for these selected years. And then year 1 here represents 2001. Year 3 represents 2003, and so on. So you can see that table and see year 1, 3, 5, 7, 9, 11. So what we're going to do is letting y represent the cost in year x. So y is the cost and x is the year. We have the data plotted on this graph to the right. X-axis, years, y-axis, money. And let's use the point 5, 5,491. So let's find that point. So that's this point right here. So that means year 5 represents 2005. In 2005, it says that the average cost was $5,491. So we're going to use that point, and then we're going to use the point right next to it, which is 7, 6,185. 7 represents the year 2007, so it's saying in the year 2007 the average cost was $6,185. So we're going to use those 2 points and write an equation in slope-intercept form. And we want to know how well does this equation approximate the cost, the actual cost using the data in year 2011. So we're pretty much doing exactly what we just did. So first, we know that we want the point slope formula to come up with an equation of a line. We have 2 points, the year 2005 and the year 2007 point. So we get to choose which one we want to use for the formula. But first we need to calculate the slope between them. So I'm going to let x2 y or x1 y1 be the 2005 point, and I'm going to let x2 y2 be the 2007 point. So it's going to be 6,185 minus 5,491 over 7 minus 5. So calculating this, we're going to get 347. So that means using those 2 points, the slope between those 2 points, the units would be dollars per year. So that's saying that the tuition is increasing at $347 per year. So that's going to be our slope. So we can use that formula now, point slope formula, and plug in. I'm going to use the coordinate, the 2005 coordinate. So I'm going to use the y coordinate as 6,185. The slope is 347. And the x is the 5. So I'll just write that on the side so we don't get confused where I got that from. So it's going to be, whoops, I actually just flip-flop the coordinates here. So the y coordinate for that one would have been 5,491. So now writing these coordinates up here, x1, y1 that I'm using for the point slope form is 5, 5,491. Okay, so let's put this into slope-intercept form by solving for y. So we would have to distribute the 347. So it's obviously going to be a little messy, so obviously using a calculator here. We would get x minus 1,735. And then we would add 5,491 to both sides, and we would end up getting 3,756. So this is the mathematical model using those 2 data points to help us approximate tuition costs. So let's see how accurate this is for the year. What do the questions say? How well does it approximate the cost in 2011? So what we're going to do is 2011 as an x value gets represented with an 11. So looking at the table here. And the actual cost was 8,244. So let's see what our data says. Let's see what our mathematical model says here. So let's let I'll say in 2011, x equals 11. So we're going to plug that in. So y equals x plus 3,756. Oh, whoops. I just realized that I actually did not distribute that to the x too. So that would going to be, so going back up here, 347x minus the 1,735. And the only thing that was wrong is that the slope was wrong because I forgot to distribute that. So y equals 347x plus 5,491. There we go. Okay, so I just have to fix it down here. So y equals 347x plus 5,491. Just making sure I didn't mess anything else up now. Okay, so it looks good. So now we just have to plug in x equals 11. So that's going to be 347 times 11 plus 5,491. And that's going to give us $11,508. So based on our model, it says in the year 2011, the cost of tuition would be $11,508. Going back up to what it actually is, it's actually $8,244. So it actually did not model it very well. So I'll make a little note down here that the actual cost was $8,244. So it did not model it very well using our model here. Actually, I made one more mistake here. I promise it's the last mistake. So this slope right here, I forgot to, when I added 5,491 to both sides, I forgot to subtract the 1,735. So this number, this y-intercept technically should have been 3,756. And then this last part we did over here in the light blue, that would have changed this number, and I actually think the answer would have been a little bit more reasonable here. So it would have been 347x plus 3,756. So we plugged in 11, and we should get 7,573. So, okay, so that makes more sense. I kind of figured there was a mistake somewhere in there, so I had to pause and go back because the number seemed a little bit too far off for the data that seemed like it was pretty linear. Okay, so the number that we got based on the data was 7,573 in 2011, and the actual cost was 8,244. So our approximation, our linear model approximation, was actually reasonably close to the actual value. Okay, so sorry about those little mistakes in there, but now they should be all fixed. But that's it for 3.5.